Okay, this is a little lesson about something called the binomial theorem. So we're going to start off with something that has absolutely nothing to do with the binomial theorem. And that's talking about what this means. Okay, so this is a way that we can write down something called a combination. Combination is simply out of a group of n things, right? N books, N students, N animals, N options at Sonic. How many are we choosing at a time? Okay, so the N value is your total number of options that we have available to choose from. And R is how many we are choosing at a time. Okay, so it says N things taken R at a time. So out of 6 things, can you choose, how many different ways can you choose 3 of them? Right, out of 35 students, how many different ways can we have a president, a vice president, or how many different ways can we have 3 chair people? Right, president, vice president, that matters. Those are called permutations. But when order doesn't matter, it's a combination. And combination has a formula, okay, that have these exclamation points in them. Exclamation point is known as factorial. So n factorial over r factorial times n minus r factorial. The exclamation point means factorial. Okay, so that's a formula, right? Everything, well, pretty much everything has a formula. And that will tell us how many ways we can take r, or n things r at a time. Okay, so we'll talk about this later in a second, but it's a pretty easy thing to do. Okay, so here we're going to evaluate 3, 1. 3 options. How many ways can we choose one of them? So this is your n, and this is your r. This is your formula. Okay, n factorial divided by r factorial times n minus r factorial. Okay, this becomes 3 factorial over 1 factorial times 3 minus 1 factorial. Okay, so 3 factorial over 1 factorial, 2 factorial. So what does factorial mean? Well, that is the mathematical symbol for multiply all the stuff smaller than this together. So 3 factorial means 3 times 2 times 1. That's what 3 factorial means. 1 factorial means 1, of course, because 1 times 1 is itself. 2 factorial means 2 times 1. Okay? So 3 factorial means 3 times 2 times 1. 2 factorial means 2 times 1. So what kind of things can we cancel out top to bottom? The 1 divided by 1, the 2 divided by 2, and our answer is 3. 3 divided by 1 is 3. So there are 3 different ways that out of 3 items, we can choose one of them. So if I had 3 items, A and B and C, I can either choose A, that's one way, I can choose B, that's 2 ways, or I can choose C. There's 3 ways that I could choose one item out of 3 things. That's what this means for a combination. Okay? So number B says 8, choose 2. So I have 8 items, right? I have 8, A, B, C, D, E, F, G, H. How many different ways can I choose 2 of them? 1, 2, 3, 4, 5, 6, 7, 8, right? We don't want to have to count all these different ways because A can pair up with any one of the other 7, and B can pair up with any of the other one of the 6. So we're going to use a formula rather than try and just count them all. So this is 8 factorial over 2 factorial times 8 minus 2 factorial. Okay, so your n value is 8. That's how many total things we have, and we're choosing them 2 at a time. So out of 8 people, we're choosing 2 to represent us. How many different ways can we choose 2 people out of 8? Okay, so 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 8 factorial. 2 factorial is 2 times 1, and then of course 8 minus 2 is 6 factorial. And it's all multiplication. We're multiplying all of these things together. So we're going to do some simplifying here in a second, so you don't have to write all this stuff out. But all of these will divide each other and give you 1. Okay? So we basically have 8 times 7 divided by 2. 8 divided by 2 is 4. So we basically have 4 times 7. 4 times 7 is 28. So there are 28 ways that out of 8 people, we can choose 2 of them. 8, choose 2. There are 28 different ways to do that. Which brings us close to our binomial theorem. Okay? So it turns out that this French guy, Pascal, was doing a whole bunch of work with this algebra stuff, of course, because he loves doing algebra. And he was multiplying a whole bunch of things together and found out that there's a pattern. Okay, if I were to multiply a times b, right, that's a binomial. Binomial means 2 terms, so I'm multiplying 2 terms together, and I'm going to raise it to the 0 power. What is my answer? Anything raised to the 0 power is 1. Okay? So anything raised to the 0 is 1. Okay? And then he did a plus b to the first power. And anything raised to the first power is itself. So there are how many a's? And how many b's? 1a and 1b. Right? And he kept doing this over and over and over, because what else are you going to do in the 1700s with your time? Except for do a lot of math, apparently. And he came up with this pattern. Okay? He noticed that there was a pattern to all of these problems. That if you raise a binomial to a power, that you get this pattern. Well, this triangle can be formed without knowing anything about binomials or anything else, because we form the next term in your triangle by adding the 2 terms above it. So here we have the coefficients of your, what are these? Coefficients of each term. Okay? So if you go to this line, 1, you just drop down to 1, of course. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then we have a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So you can make this triangle simply by adding the 2 terms above it. And these are going to give us all of your coefficients of your terms of your binomials. Okay, so that's where we're going to start when we get to our binomial theorem, is by looking at the row of our Pascal triangle. So let's come over here and look at this theorem. Okay, which is this is some crazy math notation, but this is what the binomial theorem says and how it's written. Okay, it says if I were to take 2 terms and raise it to any power, right? So here's your binomial, your 2-term math problem raised to any power. It's as if the coefficients were your combinations. Okay? You can form the coefficients from Pascal's triangle, the 1, the 3, the 3, the 1. Those come from a combination. Okay? So if you don't know your Pascal's triangle, you can always do a combination to figure out what the coefficient is. So there's 3 parts, and this is how we're going to do it. Part number 1 is the coefficient. Okay, so we're always going to start with the coefficients. Part number 2 is your x term. Right? X is in parentheses here. I'm going to call it A and B. And the third one is your y term or your b term. I'm going to call it B. Okay, and there's going to be a pattern. Like most things in life, there are patterns, and if you can recognize them, then we can use the pattern to predict what's going to happen and maybe make life easier for someone somewhere. Okay? So let's use that pattern to expand x plus 2 to the 5th power. Okay, so I'm going to call this my A term. I guess A was blue, so let me change back to blue. My A term and my B term, since it's not always x and y. Okay, so the first thing we start with is the coefficients from your Pascal's triangle. So we're going to look at the 5th level of Pascal's triangle, which is here. Here's our 5th level. So how many terms are there in the 5th level of Pascal's triangle? 6 terms. Okay, 1, 2, 3, 4, 5, 6. So these are the coefficients of your terms. 1, and then 5, and then 10, and then 10, and then 5, and then 1. So we're always going to write a plus in between here. We're adding all these terms together. Okay, so that's what we do first, is we write down the coefficients from Pascal's triangle, or we could use our combination. This is 5, choose 0. There's only one way to choose 0 things out of 5, and that's to choose nothing. This is 5, choose 1. This is 5, choose 2. This is 5, choose 3. And then 5, choose 4. And 5, choose 5. There's only one way to choose 5 things out of 5, and that's to take all of them. Okay, so if we didn't have Pascal's triangle, we could calculate that coefficient by using our factorials that we just learned a second ago. Right? We could always calculate that term if we didn't know it, which we might do later. Okay, next. Let's go to your A value, which in this case is x. Okay? So the x's always start at your highest power, and they lose a power every time you go to the next term. So it starts with x to the 5th power, and then x to the 4th power, and then x to the 3rd power, and then x squared, and x to the 1st, and even x to the 0. Okay, but what is x to the 0? 1. X to the 0 is 1. So that one is really not appropriate to put in there. So our first term, the powers count down from the highest power to 1 less every single time. 5, 4, 3, 2, 1, 0. And your B term, which in this case is 2, counts up. So it starts at 2 to the 0. What is 2 to the 0? 1. So we don't really need a 2 to the 0 there. But then we need a times 2 to the 1st. And then a times 2 squared. And then a times 2 to the 3rd. And then a times 2 to the 4th. And a times 2 to the 5th power. Okay? It's a pattern. It happens for every single one of these binomials. The first term starts at the highest power and counts down until it gets to 0 at the last term. Your second value starts at 0 and then counts up. 2 to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th. Okay, so notice the sum of your powers. 4 plus 1 equals 5. 3 plus 2 equals 5. 2 plus 3 equals 5. 4 plus 1 is 5, right? That's always going to happen. The powers added together will always be the same as the power of your binomial. So now it's just a matter of simplifying. 1 times x to the 5th is x to the 5th. What is 5 times 2? 10x to the 4th. Plus, what is 10 times 4, right? 2 squared is 4. 10 times 4 is 40x cubed. What's 10 times 2 cubed? So 2 cubed is 8. 8 times 10 is 80x squared. 2 to the 4th, that's 16. 16 times 5 is 80. X to the first power plus 2 to the 5th, which is 32. Okay? That is your total expansion of x plus 2 to the 5th power. So let's use that pattern to do this one. 2y plus 3 to the 4th power. So how many terms are there going to be? 5 terms. There's always one more term than there is power. So coming over here to our Pascal's triangle, the 4th row, we have 1, 4, 6, 4, 1. These are the coefficients of each of your terms. 1, 4, 6, 4, 1. We always start with our coefficients. 1 plus 4 plus 6 plus 4 plus 1, right? And always leave a space because we have to have our other 2 terms in there also. Okay, so we leave a lot of space in between your number and your pluses because we are not even close to being done. Okay? So that's where we start. Those are our coefficients from Pascal's triangle. This is 4, choose 0. This is 4, choose 1. This is 4, choose 2. This is 4, choose 3. This is 4, choose 4. Right? We could also use our combination formula if we didn't have our Pascal's triangle handy. So now let's look at your first term, which is called 2y, right? So we're going to do 2y and raise it to the 4th power. And then we're going to do 2y and raise it to the 3rd power. And then 2y raised to the 2nd power. 2y raised to the 1st power. And then 2y raised to the 0, which we don't ever include the 0 power in our problem. Now we move over to our second term, which is -3. Okay? So we start with -3 to the 0, which is, of course, 0, or 1, so we don't need to include that one. So here we have -3 to the 1st power, and then -3 squared, and then -3 to the 3rd power, and finally -3 to the 4th power. Your first term counts down 4, 3, 2, 1, 0. And your second term counts up 0, 1, 2, 3, 4. Okay? So that's using our pattern with our terms and your coefficients from Pascal's triangle or from our combinatorics, right? Your combinations. So now let's do some simplifying. This is 2 to the 4th times y to the 4th. So 2 times 2 times 2 times 2 is 16y to the 4th. Plus 4 times, what is 2y cubed? So that's 2 cubed. Y cubed is 8y cubed times -3. Plus 6. 2y squared becomes a 4y squared. What is negative 3 squared. That's positive 9. Plus 4 times 2y times, what is negative 3 to the third? Negative 27. Plus 1 times negative 3 to the fourth is positive 81. Okay, so we are expanding each of our little terms, right? We multiplied our blue terms out, and then we multiplied your purple terms out. So now we have to multiply all of our numbers together, right? So 16y to the fourth, that stays. We have 4 times negative 3, which is negative 12. Negative 12 times 8 is negative 96y to the third power. Okay, 4 times 12 is 96, but because it's negative, we're going to change our plus sign to a minus. Now we have 4 times 6 times 9, which is 36 times 6, is that 144? Right, and that's a positive because all those numbers are positive. And then our next one, this is going to be a negative because I have a positive 4 times 2 is 8. 8 times negative 27, 56, 16, 215 y plus 81. Okay, so I think the hardest part might be multiplying all of these numbers together if you don't have a calculator handy. Okay, but this is how we use our binomial theorem to expand. It's not 144, is it? It's how many? 216, 36 times 3. Yes, I did not carry the 45. Thank you. 216y squared minus 215y plus 81. Okay, so there's 3 parts. The first part is your coefficient, either from your combination or from Pascal's triangle. The next is your first term raised to the power and then subtract 1 every time. And then your third is that second term starting at 0 and going up. And then we multiply it all out and you get one final fabulous answer.